So here's our next video, part 284C3m1b7a17, line 22f1fa19c3m1b7a17, asymptotic freedom nuclear interactions atoms 5G Wow Seti. So this is keywords to be filmed. So this is just basically keyword research in this one. So there's the alien radio signal, and the keyword is asymptotic freedom. In physics, asymptotic freedom is a property of some gauge theories that causes bonds between particles to become asymptotically weaker as energy increases and distance decreases. Asymptotic freedom is a feature of quantum chromodynamics, the quantum field theory of the nuclear interaction between quarks and gluons, the fundamental constituents of nuclear matter. Quarks interact weakly at high energies, allowing perturbative calculations by dglap of cross-sections in deep, inelastic processes of particle physics, and strongly at low energies, preventing the unbinding of baryons, like protons or neutrons with 3 quarks, or mesons, like pions with 2 quarks, the composite particles of nuclear matter. November 27, 2012. We talked about how to split an atom to create fusion in the other videos. This gives us an even bigger picture on the properties found in bonds between particles to become weaker or stronger with QCD. The keywords are nuclear interaction between quarks and gluons. So I'm going to Google nuclear reaction, and I found this graph here. Quote from Wiki: the same diagram with the individual quark constituents show to illustrate how the fundamental strong interaction gives rise to the nuclear force. So November 20, my thoughts. A strong interaction equals nuclear force. Quote from Wiki: straight lines are quarks, while multicolored loops are gluons, the carriers of the fundamental force. Other gluons which bind together the proton, neutron, and pion in flight are not shown. So my thoughts. Gluons plus carriers equals force. Another quote from Wiki: the nuclear force is only felt among hadrons. At small separations between nucleons, less than 0.7 FM, between their centers depending upon spin alignment, the force becomes repulsive, which keeps the nucleons at a certain average separation even if they are of different types. This repulsion is to be understood in terms of the Pauli exclusion force for identical nucleons such as 2 neutrons or 2 protons, and also a Pauli exclusion between quarks of the same type with nucleons when the nucleons are different, a proton and a neutron for example. As will be discussed, the nuclear force also has a tensor component which depends on whether or not the spins of the nucleons are aligned or anti-aligned. November 27, 2012. My thoughts. The separation between nucleons, the force becomes repulsive. We want this kind of force with our antimatter alien Wow formulas for the space elevator and UFO spaceship idea. Quotes from Wiki: energy is released when a nucleus is created from free nucleons or other nuclei, the nuclear binding energy. Because of mass energy equivalence, Einstein's famous formula E equals mc squared, releasing this energy causes the mass of the nucleus to be lower than the total mass of the individual nucleons, leading to the so-called mass deficit. So we have lithium-6, deuterium H2, alpha particle, He4, right? Lithium-6, deuterium reaction. In this symbolic representation of a nuclear reaction, lithium-6, 6L, and deuterium react to form the highly excited intermediate nucleus H8-4b, which then decays immediately into 2 alpha particles of helium-4. Protons are symbolically represented by red spheres and neutrons by blue spheres. Keyword nuclear reaction. In nuclear physics and nuclear chemistry, a nuclear reaction is semantically considered to be the process in which 2 nuclei, or else a nucleus of an atom, and a subatomic particle, such as a proton, neutron, or high-energy electron from outside the atom, collide to produce one or more nuclides that are different from the nuclides that began the process. Thus, a nuclear reaction must cause a transformation of at least one nuclide to another. If a nucleus interacts with another nucleus or particle, then they separate without changing the nature of any nuclide. The process is simply referred to as a type of nuclear scattering rather than a nuclear reaction. So my thoughts are: you need the nucleus of an atom plus a subatomic particle like a proton, neutron, high-energy electron. Outside the atom, you want to collide, produce 1 plus nuclides, different particles from original one, equals nuclear reaction, transformation, one nuclide to another. Okay? Thanks for watching, and we'll go on to the next video soon.